Welcome back, everyone. This is part 3 from chapter 1 or module 1, and this is collecting sample data. And the main thing we want to keep in mind is whenever we're collecting sample data, we want to identify biases. That's our own biases and other people's biases. We want to, if not, we would try to eliminate them, of course, but if not, we at least want to be mindful that they're there and kind of keep an eye on that. So statistical methods are driven by the data that we collect. We typically obtain data from 2 distinct sources. And we have 2 more definitions here. Our first one is an observational study. In an observational study, we observe and measure specific characteristics, but we do not attempt to modify the subjects being studied. That's versus an experiment. We apply some treatment and then proceed to observe its effects on the subjects. The example that I usually give in class for an observational study would be, let's say I set up some cameras in my classroom and didn't tell anyone, and I wanted to do a study to see who checked their cell phone more often, men or women, something like that. And the students wouldn't even know that it was being done. That's an observational study. Observational studies are when people go out into the Serengeti and they want to observe lions or something. They don't want to interfere with the lions. They don't want to change the lion's behavior. They just want to observe what's going on with the lion. Versus an experiment where you go in and you say, this person is going to take this medicine. This person's going to take some pretend medicine called the placebo. And then we take a look to see that that's going to be an experiment. Let's practice a little bit. So determine whether the given description corresponds to an observational study or an experiment. First one, a marketing firm does a survey to find out how many people use a product. Of the 100 people contacted, 15 said that they use the product. That is going to be an observational study. They just want the information. They just want to know. Now, what you do with that information, that's the next step, which we're not going to get to right at the moment. A clinic gives a drug to a group of 10 patients and a placebo to another group of 10 patients to find out if the drug has an effect on the patient's illness. That is definitely an experiment. A sample of fish is taken from a lake to measure the effect of pollution from a nearby factory on the fish. That is also an observational study. You might think that that's an experiment. An experiment would be if you went to a certain part and you gave a medicine and wanted to see, and then you collect them again and see if the medicine was helping with the pollution or not. That would be an experiment. But for now, they're just observing. A quality control specialist compares the output from a machine with a new lubricant to the output of a machine with the old lubricant. That is definitely an experiment. You're checking to see if the new is better, if the old is doing just as well or not. All right, a few more definitions. And we're going to talk about good ways to gather data and poor ways to gather data. Our first good way to gather data is called a random sampling. In a random sampling, members from the population are selected in such a way that each individual member in a population has an equal chance of being selected. So your stereotypical one would be something where everybody would have the same size piece of paper. They would write their name on it. They would fold it in half, and then everybody would put the paper into a bag. They shake up the bag, and you reach in and pull one out. That's your typical random sampling. Of course, we have better ways to do that now with computers. And I won't get into the whole random with computers, but yeah, so that's what we think of when we think of random. Next up is systematic. Sampling. We select some starting point and select every kth element in the population. So for example, if I were in a classroom, I would start with, I wanted to gather a few people. I would start with one person and then maybe count 1, 2, 3, 4, the 5th person behind them, then 1, 2, 3, 4, 5, 5th person behind them. And so every 5th person I'm choosing. That's what they mean by every kth element. Next up, we have stratified sampling. We subdivide the population into at least two different subgroups, which is where the word strata comes from, so that the subjects within the same subgroup share the same characteristics. Then we draw a sample from each subgroup. So this would be if I were in a classroom and I were to say all of the teenagers go to this wall, all the people in their 20s go to the back wall, all the people in their 30s go to the side wall, and all the people that are 40 and above come to my wall. So they're broken up for a specific reason, right? In this case, by age. And then what I would do is I would select maybe 3 randomly from each group. That way, each of the strata or the subgroups have a representation. This is often done when choosing committees at like a college, where we want to make sure that we have some people from math and English because we're talking about basic skills, or we want to make sure we have someone from the trades to make sure that they're represented in this group. So this is a common way of doing things. And last up for the good ones are cluster sampling. This is where people, or the population, is broken up into clusters. And there's no real meaning. Like the previous example we had, it was broken up by age. The grouping would be maybe like rows in the classroom. There's no real, there's no age or anything connected to that. But once they're broken up, then you select a few of the groups and you sample everybody in those groups, versus the stratified, where you break them into meaningful groups and you only gather a few people from each group. All right, we now have the bad. So these are not good ways to gather data. So purposive or judgmental, and I'm not going to read all that to you, but this is what we try to avoid when we're doing an experiment. What we don't want is someone going into an experiment with an intended outcome, meaning I'm going to go into this study, but I really want the outcome to say this. So for example, if we wanted to do something like, does God exist? So then you would go to, if I went to a church or a synagogue or a mosque and asked them if they think God, of course, I'm really biased, right? I'm trying to get the answer that I'm looking for. Or in the other direction, I could go to an atheist convention or something like that and ask them. That would, again, I would be forcing one way or the other, and that's a terrible way to gather data. Convenience sampling, that's what I call lazy. That's where, let's say I wanted to find out the average height of the students at a particular college. And what I do is I just go, you know what, my students are already in my classroom. I'm going to use their heights to represent the entire college. That's convenient sampling. It's not a very good way of doing that. The third way is the quota. A quota is when you have a minimum or a maximum, something or other to do. So for example, and the reason this is bad is because let's say that I'm out and I'm giving out pamphlets, and the more pamphlets that I give out, the more money I get. And so what I might start, I give more out, is I might start distorting what's actually the paper means and trying to say things to get more people to come, and then I'm sort of lying and things like that. So having a quota is not a great way of doing that. And all three of these are often used. And so it's good for you to keep an eye out so that you don't do it yourself, hopefully. All right, let's practice a little bit. So let's start with our first one. An ecologist uses the line transect method by stretching a rope across a lake and collecting samples at every interval of 5 meters. This is definitely systematic. And this is the kth, right? Every 5 meters. Okay, go back to the definition. Next up, to determine her stress level, Hannah divides her day into 3 parts: morning, afternoon, and evening. She then measures her stress level at 2 randomly selected times during each part of the day. This is definitely stratified, meaning it's broken into 3 meaningful parts, so different times of the day, and it's only 2 times during each of those pieces there. A survey is conducted by randomly selecting 7 schools in the area and then interviewing all the teachers at that school. So that's the key for this one. This is the cluster. A researcher interviews the first 30 patients who entered a clinic with arthritis. That is definitely the convenience one. In fact, I'm gonna write that in red. Ooh, and I'll leave it at con. So that's not a very good way to do a study. Not a serious study anyway. A researcher is examining coffee prices in New York. First, random numbers are assigned to each shop, and then every fourth shop is chosen from the list. This is systematic. Every fourth. All right, this one's a little long. Researchers are attempting to determine the average height of trees in a park. The number of trees in the park have been tallied, and there are 400 total trees of various sizes. Each of the 400 trees are entered into a list in the computer, including information about the variety and location. This list is then randomized so that it is not in any order, and arbitrary numbers are assigned to each tree. The researchers or computer program then selects at random, without bias, a selection of trees from these meaningless numbers. These would be the trees that would be measured for the study. All of that breaks down to random. So even though the numbers were assigned and all that kind of stuff, because everything's selected at random. And by the way, just because you see the word random doesn't mean that it's the method is random. Last one. A researcher organizes the population of students in a college by college class. Freshman, sophomore, junior, senior, and then randomly selects appropriate numbers of freshmen, sophomore, juniors, and seniors. This is stratified because they're broken up into meaningful pieces, and then only some from each group are selected. And very lastly, I have some fun pictures down here to kind of represent this. Here's everything broken down. So we have the bad ones and the good ones of our samples. Here's our random sample. Here's our stratified. I'm sorry, this is our systematic, every third, pardon me. Here's our stratified, broken up into specific groups. If this were in color, it makes a little bit more sense. And then only some from each group are selected. And then this one is quite small, but this is districts in a voting, and they select 3 random districts and talk to everybody in those districts for that. I hope that helps.